Alright, it's your boy Chili. I'm back and we are here to make Snick America great again. So let's do that. So let me ask you a question. Did you have any problems working on the Snick game? Because I hope you did. Sounds like a dick thing to say, but I got your best intentions in mind. See, you gotta have these bumps in the road. That's where you really learn from. So it's not going to be easy in the beginning. There's going to be a lot of shit that you don't understand. You're going to make mistakes, and the compiler is going to complain at you hard, and it's going to be complaining in a language you don't understand. But you got to work through it. You got to Google that shit, and if you still don't understand, you got to ask on the forum, ask on the Discord. It's the same thing. If you build the program and it runs, but it's doing weird shit, you got to pull out that motherfucking debugger. The debugger is super important. Learning how to understand compiler speak and learning how to use your debugger are two super important skills that you're going to need to learn. And the only way you're going to learn is if you fall on your face. So I hope you fell on your face hard. And there were a couple of little pitfalls in there. I've actually put a note into the wiki page about them. One of them was a bug, and that was covered in the second part of the tutorial. The bug in Snake Grow. But then the other thing was the fact that you have to call move by right after you grow the snake. You can't grow and then draw. You got to call move by, otherwise your shit's gonna go bad. But anyways, you can check that on the wiki. I'm sure if you made it this far, you've already solved that thing. But yeah, problems, setbacks, these are good things as long as they don't make you give the fuck up. And honestly, if you're gonna give up, you're gonna do it sooner or later, so you might as well do it sooner, right? But hopefully you never give up and you become a fucking pro. And if you feel like maybe you're losing hope, don't give up right away. You know, come give us a word in the Discord or on the forum, and someone will help you out. We'll set you straight. So anyways, here is the solution to the homework. We got a list of tasks. Let's go down that list. We got to solving the problems, working together. And that's what we're going to do. So, first things first, let's make it so that we can, move, or we can draw the board at any arbitrary position on the screen. Because we'd like to center it in our window. So we'll add a couple of const expression int x and y here for the position that we're going to draw the board to. I mean, like these other things, I could just make this a normal member variable, but I don't see the point in our current usage situation. So anyways, let's use these values to draw the board. So what we're going to do is we're going to go into draw cell, and so I guess the offset is just going to be, so we got location x times dimension. What we're going to do, and this is kind of looking forward, we're going to go const int off x, that's the offset x is just equal to x, and then constant int off y is equal to y, and we're going to use these guys, we're going to add them to the starting positions of the rectangles here. So off x, and let's just copy this like this, copy, and we'll paste that in there. We'll replace that with a y. And I'm doing this because later on this offset expression is going to become more complicated when we add the border. But for right now, this is the way it is. So we build that, just make sure we haven't broken anything. And it looks like it's probably still fine. I mean, we can't really see where the board begins and ends because it's all black. But, I mean, it's probably working. Let's continue. So, we got the offset x and y. We can set it by changing these static const expression variables in here. Now, the next thing is we want to draw a border around our board. So, the border is going to be, the top left-hand corner of the border is going to be just the x and y position of the board. And so, it's going to have a width. First of all, we're going to draw it with 4 rectangles like this. The top and the bottom rectangles are going to span the entire width. And the left and the right rectangles are going to be the left side and the right side minus the parts that are covered by the top and the bottom rectangles. So, we're drawing these rectangles. They're going to have a set border width, which is going to be another constant that we define. And we've got to calculate their dimensions or their positions of the points. I don't know. It depends. We got two versions of draw rect we can use. And I'm not sure which one I'm going to use. Probably the version that takes left, right, top, and bottom, if we're going to be honest here. So what I'm going to do is I am going to pre-calculate the top, the left, the right, and the bottom coordinates for this outer region of the border. And then I'm going to use that to calculate the data values needed to draw the border rectangles. So what we're going to do here is we're going to go into draw rect. Let's draw a cell. We got to add a new function first of all. We're not going into draw rect. I misspoke. We're going to go into this one here. We're going to go void draw border. And we don't make that const because we're changing graphics here. And we'll create the definition like that. All right. So constant int top is just equal to x, right? It's just going to be equal to x, I believe. Constant int left is equal to y. This seems to make sense. Except that these are backwards, so don't do that. Disregard, please. We are going to make the top and like that and like that. Okay. Now, the bottom, here's where it gets interesting. Now, generally when you specify a rectangle, you specify exclusive coordinates for the bottom and the right, meaning the value that you specify on the right, it's going to draw up to but not including that coordinate position. And the same with the bottom, it's going to draw up to but not including the bottom. So anyways, that's just, you don't have to worry about that. So the bottom, the coordinate of the bottom is going to be the top plus twice the width of the border plus twice the padding between the border and the actual board or the table, plus the size of a tile times the number of tiles in the height direction. So let's break that down into code, shall we? We'll go back here. So what we're going to do is constant int bottom is equal to top plus, now we should close that. We're going to add a few more static const expressions here. Width and height, static const expression int border width, I don't know, we'll say it's 4. And static const expr int border padding, that's the padding between the border and the actual board. And we'll say that's 2. Could be 1 or 2, I don't know. We'll say it's 2. And so, what do we got here? So it's top plus border width plus border padding, and we'll multiply that whole quantity by 2 because, you know, there's 2 borders and 2 paddings between the top and the bottom, plus height times dimension, which is the dimension of a tile in the grid of tiles. So that should give us our bottom coordinate. And if we do the same thing for the x, we should get something like this. And now we want to actually draw those 4 rectangles. So let's start with the top one. What are we going to do? Okay, so first of all, we're drawing border. We're drawing something. So we definitely need... Oh, wait, we don't need graphics because, yeah, we cached that. Never mind. Scratch that. gfx.drawRect. Now we're going to draw a rect with the x0 and x1, y0, y1. So x0 is just going to be the left. Y0 is going to be the top. Now x1 is going to be the right. And y1 is going to be the top plus the border width. And then the color, oh, we need a border color. So we'll toggle this mother. And we'll go. We got so many static const expressions here, it's not even funny. Const expression color, border color is equal to colors, and we'll just use blue. Alright, so border color. Let's copy that, toggle. Put the border color in there, and all's great. And it makes sense, right? I mean, left, top, right, and this one isn't bottom because bottom is down here. This one is top plus border width. So, using that same logic, we can derive the rectangles for the other four, the coordinates for the other four rectangles. So for example, for this rectangle here, we've got left, top plus border width, and then we've got left plus border width, and we've got bottom minus border width. And that'll give us the top, bottom, left, right for this rectangle here. And you see that's what we got here. So let's do the same for now the bottom and the right rectangles. And here's what you end up with. I added some comments here just to, make it easier to read which call is drawing what. And there you go. So let's, this should just work. Maybe I'm wrong, maybe I'm smoking some of the wacky tobacco, but I think this should just work. Nope, didn't work. Okay, well, of course it's not going to just work because we're not actually calling it. We got to go into game.cpp. Where is it? There it is. And down here, we got to call it somewhere. So let's call it at the end, I guess. We'll go brd dot draw border. And we'll build that. And if we run it, now we got our border. And now we can see what the hell we're doing. Is that too much of a... It almost seems like, I don't know, it seems, let me think here, let me collect my thoughts. It seems like the whatchamacallit, the padding is a little bit too much. Nope. The problem was somehow we're not taking, right. We're not taking the border and the padding into account when we're drawing the actual grid of cells, because we never changed that. That's obviously a problem. So let's go into board, board.cpp, and we'll go, where is it? Draw cell. So remember here, I created the offset X and offset Y. This offset now has to account for the fact that we've got this border here and this border padding that we're drawing at X and Y. So it should be X plus border width plus border padding. And we'll do the same for Y. Like this. Now if we build this, it should be okay. Maybe. Let's see here. 1, 2. There we go. So now we've got our padding of maybe 1 or 2 pixels. I can't really tell there. That's not very much. I think actually our padding might be off a little bit on the top. Because, I don't know, it looks, let's go on the bottom here. On the bottom it looks very thin. On the side, a little thicker. But you can't really be sure with these pixels, because especially when you're dealing with primary colors like red, RGB, red, green, and blue, some things can seem closer than others because of the way the pixels are laid out, the colors inside of each pixel. But, man, it looks pretty good to me. I don't know. I'm going to say it's good. So we've got that. And I would like you to notice there that because we created this board class, all of this kind of changes we've made to the aesthetics of the drawing, we didn't have to change one lick of anything in Snake or in Goal. The logic part of our game didn't need any changes. We just had to change the board class and a little bit in main. All right, now there's one more change that we can make if we like, and that is we can create a little bit of padding between cells. So we'll go const expression int cell padding is equal to, and we'll make 1 pixel of padding between each cell. And how this is going to work is, let's see here. So it's only going to affect the drawing of the grid itself. The border will stay the same because the actual cell dimensions will stay the same. Just the parts that are colored is going to be a little bit less. So in here, what we're going to do is we're going to go, so dimension x plus offset x, and we're going to add, let me think here, cell padding. So we're going to offset the x and y by the padding amount. Here, offset y plus cell padding. Yes. And in here, dimension, we're going to subtract, where's my home row? Here it is. Subtract cell padding times 2, right? Because the dimensions, the actual width of the rectangle that's being drawn, let's go back in here. So you're drawing a rectangle here. Before we were drawing like this, right? Rectangles like this flush to each other. Now we're going to be drawing like this with a little bit of padding. So the width of the rectangle being drawn is just going to be the normal width minus the padding amount times 2, because you're subtracting it from this side and from this side, and same from the height. So you got to subtract cell padding times 2 for that, mother. So we'll go up into here, we'll subtract cell padding times 2, and this one will do the same. I mean, for performance sake, we could pre-calculate this, but I'm pretty sure the compiler will do it for us. It'll probably just like compute this multiplication once and then use it in both places. And the same for here, but even if it doesn't, it's not the end of the world. It's not going to make a lick of difference for us. It's not a big performance bottleneck. So now if we draw this, our square is going to be a little smaller, and they should now not be connected. Fuck you. Down. There we go. So yeah, so now you've got 2 pixels between each cell here, and you've got a little bit more space also between the cell and the border. Not a lot, but enough. So I like this. This is good. Now we can tell, you know, when we're gonna die when we go up against the edge of the world there. Did I just? No, I didn't. I didn't actually collide with myself there. Let me just see. Okay, there you go. Game over. Perfect. All right. That reminds me of the next thing we're gonna be doing, which is, you know, add the frickin' title screen. So let's go into game.cpp. This shouldn't be a real big problem for you guys at this point. Bool game is started equal to false. So if not game over, we do this. And then we do that. So if not game is started. And what we're going to do here is we're going to bypass all this bullshit if game isn't started. If not, wait. So if game is started, enter this and do this bullshit. But if it's not started, else, game is started equal to, and we're going to be doing the old window.keyboard.key is pressed vk underscore enter. Or is it return? It is return, isn't it? I was getting mixed up. Return retrun. There we go. All right, so there we go for setting up game is started. Now here, if game is started, do this bullshit, stop it. Otherwise, We're gonna go sprite codex. Fuck you. Sprite codex and draw title. And I don't know really where to draw it, so I'm just gonna draw it at 200, 200 again. There we go. All right, build that mother. Let's see what we got. And now we get the beautiful snake title. Press enter, and we press enter, game starts. And if we die a horrible, horrible death, game over. So, that's another one bites the dust. We got the title screen all set up there. I mean, I could, fool around with these numbers and, center it properly. Actually, I guess I will do that. Wait a second. Okay, so by the highly scientific methodology of fucking around with values, I managed with the width and the height of the board to be these values, the X and the Y to be this. And if we go to game.cpp, I set the game over screen to this position, the the title to this position. And if we run that, we get the snake here. We get the board looks like this, and the game over roughly about in the middle of the screen. It's all fucking good, man. All right, the next task that we're gonna have is to change the aesthetic appearance of our snake. So right now we just got one color for the head and a different color for the body. But what I want to do is give the body a repeating pattern of colors. So basically the body is going to have 3 different colors. They're just different shades of green. So 3 shades of green, and it's going to go dark, medium, light, medium, dark, medium, light, medium, dark, again, repeating in that pattern. So how are we going to do this in code? Well, what we can do is we can create an array with our colors in it, and then we can cycle through those colors throughout the whole body when we initialize the snake for the first time. So what we're going to do is we're going to go into snake.h, and we're going to check out its constructor here. So where's the constructor for the snake? Where's the freaking snake constructor? There it is. Snake, good. All right, so init head, nah dog. We got something else going on here. So what we're going to do is we're going to go const expression int n body colors, and we're going to set this equal to 4. Remember I said 3, but just bear with me here. And then we're going to go constant. Yeah, we'll go const expression, doesn't matter. Const expression int body colors and n body colors. And we're going to create an array, and we're going to initialize it here. So we can do that by using these square brackets. And then we can initialize the colors also with these brace initializers. I said square brackets before, it was braces. But this is obviously not going to be an int, it's going to be colors. So const expression color, and we're initializing 4 colors. Now why 4, you say? Well, remember the pattern is you have to go low, medium, high, medium, and then low, medium, high, medium. So it's a repeating pattern of 4. Low, medium, high, medium, and then again low, medium, high, medium, and then again low, medium, high, medium. So 4 here, low, medium, high, medium. You see this one's the same as this one. And we're just going to cycle through those and initialize the colors of all of this unused segments before we even start using them. So we're going to loop through all of the segments in the array, and we're going to initialize the body color of each of those segments to one of the colors inside of this array. Now there's a couple of things. First of all, we need a function here, init body, that takes a color. So right now the init body is taking, what is it taking? It's taking the body color here. But now the body color is going to be dictated by that array, so we don't need that anymore. So we'll go into there, and we'll go init body, and we're going to take a color C. And now we got to toggle over here. We go to init, where's init body? Here it is. We'll make it take a color C, and we'll go, it can't be C. It's got to be C underscore in. And then we're going to go C in like this. So The member variable c is equal to the input c, like this. That's how we will initialize our bodies. Now, grow is not going to call init body anymore because it doesn't need to, right? The body colors are all going to be initialized when the snake is initialized here. Now this is the magic that's going to happen. Normally, we're indexing through all of the segments, and we're giving them a color from this array of colors. And this index is the same as the index from the segment. But this array only has 4 elements, and our segment array is going to have probably like 100, right? So very quickly, your index is going to go past the end of this array. And that's not a good scene. You never want to index past the end of your array. What this does, this is the modulus, and this gives you the remainder of a division. So if we step through this, what's going to happen is first index is going to be 0. 0, and this end body colors is going to be 4. So 0 divided by 4 is, it's 0, and remainder 0, right? So this is going to return 0. And the same for 1. 1 divided by 4 is 0, remainder 1. So this is going to return 1. So it's going to index here. Next one's going to return 2, index here. Next one's going to return 3, index here. Here's where it gets interesting. Now we reach index of 4, indexing into the 4th segment. 4 divided by 4 is 1, remainder 0. So this is now going to be index 0. It's going to return to here. And then here, 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 and then it's going to return to here. So we can use the modulus to constrain these indexes to between 0 and 3. And always looping through those values, even though the index is going to be getting higher and higher up to 100 or up until 99. So that's how this works. It's the modulus operator. It basically goes together with integer division. It's the yin to its yang. But anyways, so if we do this, we should be able to initialize our body with a bunch of sweet-ass snake colors. Initialize that. So first we got the head, it's yellow. This is known. Next we got our body. It's got a nice well-toned green, if you do ask me. Next one, it's got a green, but it's a little bit different. All right, our snake is getting very long indeed now, and I like the effect that we're getting here. It's a nice aesthetic. So I am satisfied with these results. And there's how you do that. We use the modulus operator here. You don't have to. You could do it with, a loop and maybe some if statements. If you remember back when we did the glowing thing in the Pooh game or whatever it was, we did a thing where it was increasing and then decreasing, increasing, decreasing. You could do the same for an index going into here. You didn't have to use the modulus. It's not like, oh, Chili, you gave us a problem, but you didn't tell us what we needed to do to solve it. No, I'm just showing you a different way of solving the same problem. But you could have done it without this. Moving on. Now, if you want to make the snake speed up during gameplay, it's not that hard. First off, you're going to make the move period so that's no longer a constant. And you're going to have another counter in here. We'll call this one the snake speed up period. And we'll say it speeds up every, I don't know, like 2 seconds or 3 seconds. That's 180 frames if you're running at 60 frames a second. And then we're going to need the snake speed up counter, or counter if you prefer. And we'll set that to 0. And it's the same idea for moving the snake here. All you're going to do is you're going to have a deal in here. So snake move counter, blah, blah, blah. And we'll just copy this because I like copy and pasting. And we'll just snake speed up for all the things here. And if we reach the speed up period, then we go snake speed up counter is equal to 0. And in here, we're going to do the snake speed up. So we go snake move period minus We could just do minus minus, really. Doesn't really matter. Put the minus minus at the front. Not that it matters, it doesn't matter. And that's it, really. So here, every 3 seconds, the snake will speed up by 1 frame of period. And if we run that, press enter. So here we're moving, we're snecking. And now here you can see that we're moving at a pretty goddamn good clip. Ah, fuck, I was too slow. Now you might want to say snake move period, and then if snake move period is less than 0, snake move period equal to 0. That's fine. That'll just keep it at, it will make it so you don't ever have actually, do you want even 0? You probably want to keep it a minimum, so we can go into here. Let's do this. Snake move counter, snake move period, static, const expression, int, snake move period minimum, and we'll say minimum at least 4 frames per move. Seems pretty rational. And we could probably even make this period a const expression, because that's not going to change. And here. And then you'd put the minimum in here and here. Now, let me show you something cool. What you can do is you can do something like this. So you can go snake move period is equal to std maximum and snake move period minus 1 snake move period minimum. And this function, it just returns the biggest out of these two. So it's either going to return snake move period minus 1. So snake move period is equal to snake move period minus 1, or just decrement snake move period. But if snake move period minus 1 brings snake move period lower than this value, it's going to return this one, which is the minimum. So it makes it so that the return value can never be lower than this one. It'll at least be the minimum. It'll never be under the minimum that we specify. And that's just standard max. There's also standard min, and that'll return the lower of the two. Very useful. We'll be using it a lot. Might as well introduce it here. I'll probably have to introduce it again in the tutorial series, for people who don't watch the solutions, but whatever. You saw it here first, folks. Now, the last thing I mentioned was, make an extension to the game by, for example, making obstacles that randomly appear as the game progresses. Now, I'm not going to do that in this tutorial or in this solution video because it's already running long. And that was kind of like an optional challenge for you to do. But, I mean, if you want to do that, I recommend. It seems like good practice, and I've already implemented it. It's not super hard. But yeah, if you're having trouble with that, feel free to come on the Discord or come on the forum, and, we'll help you out. And of course, if you're trying something other kind of extension and you can't figure something out, always feel free to come on the forum, ask for help. If you manage to do something cool or even not cool, drop by and show us what you've done. We're always interested in seeing what you guys are creating. And now, fuck. But that's the snake game, as much of it as I want to do right now. Thanks for watching. Hope you liked the video. If you did, click the like button. Helps a lot. And I will see you soon with some more C++.